Welcome everyone to the Antarctic Policy and Research webinar. As a reflection of this institution's recognition of the deep history and culture of this island, the University of Tasmania wishes to acknowledge the Muinnar and the Palawa peoples, the traditional owners and custodians of the land upon which this campus was built, and pay respect to the elders past, present and emerging. Welcome to the sixth AAPP Antarctic Policy and Research webinar. It's the second actually for this year. My name is Nathan Bindoff and I'm the program leader of the Australian Antarctic Program Partnership. This partnership is an Australian government funded initiative to better understand the role of Antarctic region in the global climate system and the implications for marine ecosystems. We undertake collaborative research, innovative science under the Australian Antarctic Science Strategy Plan and also the 20-year action plan. And finally, we're here to secure Antarctic science careers in Hobart as well. The webinar series that we have today is normally about the interface between policy and research, but today we make an exception and have a webinar on the Herculean and heroic effort it takes to solve urgent research and societal problems in Antarctica. So this webinar is about the research planning, identify the problems, get the funding agencies on board, get the research partnerships together, and also to make the connections to the logistics sufficient to get the scale and effectiveness we need to solve these critical societal problems. Just let me talk about webinar operations. You're invited to write questions into the chat throughout the webinar, and at the end of the webinar, I'll work through those questions. More questions can be added at the end, of course, and because of the size of the audience, it's not really viable to have direct questions, and so everyone will be on mute. Okay, so today's seminar, International Partnerships in Antarctic Science. Let me introduce the speakers. We have two today. They are Ted Scambos from the University of Colorado, Boulder. Ted is now a senior research scientist at the University of Colorado's Earth Science and Observation Center. Ted Scambos's research is focused on the use of remote sensing to study the polar regions and the exploration of the effects of climate change on both poles. He has been on 21 expeditions to Antarctica. Lucky fellow, I think, working with the British, Australian and South Korean and Argentinian and Norwegian research programs, and has explored almost the entirety of the Antarctic continent and the surrounding Southern Ocean. And very relevant to today's topic is that he was deeply involved in the development of the remarkable multinational Thwaites Glacier program. To complement Ted, we also have Rob Clifton, our own Rob Clifton from the Australian Antarctic Division. Rob is the manager of future operations and projects and is responsible for operational planning on seasonal and on longer timescales, and also for major projects. Prior to this role, actually, Rob was very much involved in the daily operations of the AAD for station, field aviation, shipping in the Antarctic and Southern Ocean. And very relevant to today's conversation is he was also the lead planner from Australia on multinational collaborative science and logistics programs through the Council of Managers of National Antarctic Programs, COMNAP. So welcome to our speakers, and I'll hand over to Ted Scambos to take us through the development of the Thwaites program. Ted, you'll have to unmute as well, Ted. You need to unmute, Ted.
And now
We can hear you now, Ted. We're just
Good, but something's happened to the Zoom link. Let's see, it's asking me to launch the meeting again. Can you hear me?
I can hear you very well, Ted. So I think you're
hang on, we're there, just about.
Fantastic.
Wrong one.
That's the right slide.
Sorry about that. Something, I guess maybe I touched my touch sensitive mouse and clicked off of the Zoom screen for a bit. I'd like to talk to you today about building the Thwaites Glacier program, what it took in order to assemble money from both the National Science Foundation Office of Polar Programs and the British National Environmental Research Council and British Antarctic Survey to create a group of people with the capabilities and the logistical access to explore the widest and probably the most threatening glacier on Earth in Antarctica, Thwaites Glacier. This begins with the remote sensing evaluation of the continent and the recognition, even before the time of a lot of satellite data, that this particular part of Antarctica, the northern side of the West Antarctic ice sheet, was losing ice rapidly. This map that you see is actually the elevation change map derived from ISAT, which was launched in 2003, and ISAT-2 launched in 2018. Differencing the average DEMs that were generated by those missions led to this map, which shows the rate of elevation change in meters per year. And identifies the areas of maximum concern. So you can see there's a lot of red here indicating rapid elevation change in the Amundsen Sea coast. And right in the center of that is Thwaites Glacier. On top of the discussion by Hans Weertman and John Mercer, and then later Terry Hughes, all pointing to this area of the West Antarctic coast as being important, a series of papers, important papers, came out starting around 2012 through about 2014 that really, in a way that everybody could sense, changed the level of concern and the focus about the need to study Thwaites Glacier. Starting with Ian Jockin's paper with Ben Smith on the potential case for the marine ice sheet collapse process being underway, starting with Thwaites Glacier. On the heels of that, Eric Grignot and his group had two papers submitted that came out that detailed the observational evidence that things had not only been underway for several decades, but were picking up speed, both in terms of grounding line retreat from the coast and flow speed. Then the real kicker was with Rob DeCanto and Dave Pollard and their work detailing the potential impacts of ice cliff failure on the pace of retreat along the north coast of Antarctica. That ice cliff failure could truly accelerate what's basically marine ice sheet instability, so that dire consequences in terms of the rate of sea level rise could be with us within the century or early into the next century. So that was very important. It led to several sessions at the WAIS workshop, which is a very good venue for this sort of discussion and interaction kind of format. Then AGU sessions where the problem was discussed a little bit more formally, less of that back and forth interaction. And of course, SCAR Science Conference sessions also discussed the problem, the need to do something about understanding what was going on at Thwaites better, and compilations of both oceanographic and satellite-based data showing that there was indeed an issue and that it had to do with oceans eroding the edge of the Antarctic ice sheet. Next. So again, we're going to return to this map, but mostly because I want to say that the immediate prior field work had to do with Pine Island Glacier, and a lot of that set the stage for the kinds of things we would try to do on Thwaites glaciers. There was major survey by the US program of Pine Island in 2008 to 2011. Then a bass traverse that went down the axis of Pine Island with a number of side traverses that made measurements using radar profiles and seismic to get an understanding of the shape of the basin and the layering in the ice within Pine Island. But increasingly, after the series of papers that I pointed to before came out, there was an attempt by several folks on a sort of an individual or a single proposal basis to begin to work in Thwaites Glacier. And these were, in general, given high marks scientifically, but were turned down because of the logistical challenge that they presented, that NSF by itself simply could not undertake supporting even these individual research efforts in this area. So I'm not aware of the British proposals that may also have been put forward on the UK side, but that's a subset of the US proposals that were put forward prior to a really concerted effort to organize an international program. This really is the core of the work that was done in order to put this together by the community. So it's a grassroots approach that's required. It does start with this one initiative from NSF OPP, asking the community, asking actually the National Academy of Sciences and Medicine and Engineering in the US, but to convene a panel to discuss what the next decade, and this is in the year 2015, what the next decade should look like in terms of what the top issues, what the top research topics should be for Antarctica. The outcome of that panel meeting was that the number one thing that ought to be undertaken by NSF OPP, if they have to pick and choose, would be understanding sea level rise from Antarctica, particularly West Antarctica, past and present. And when we say present, in the document, we referred to Thwaites Glacier as being the number one target to study that would help unravel that question. A major step forward. The thing that really impressed me about that left-hand document is that it included people on that panel from every aspect of Antarctic research. And the number one thing that they picked was that sea level rise question. So astronomers agreed it was the number one question. Biologists agreed it was the number one question. Geologists agreed to that as well. At the same time, there was a meeting in London by the Royal Society where they also discussed what the key questions should be, what the next steps ought to be, not a decadal survey per se, but a discussion of what the important research topics ought to be in Antarctica. And in this meeting, they demonstrated in a formal way that they intended to collaborate working on central West Antarctica, in other words, Thwaites Glacier. Lastly, the group in the US and the UK got together on a paper that was derived from some of the words that were presented in the left-hand study, a strategic vision study, and got a peer-reviewed paper put together that outlined the science plan and defined how we were going to try to get the information that we needed and feed it to modeling studies that would then give us a better roadmap for how Thwaites Glacier would come apart in the near future. So these three documents are really the core of the effort, and it took years and lots of people working together in order to make these things happen. But really with the discussions between NSF and BASS coming in the aftermath of both the Royal Society publication and the paper, the peer-reviewed paper by the research community, NSF agreed that they would take the step and make a major funding effort to, along with BASS, to conduct research in the area. So the joint call for proposals between both NSF and NERC was announced in late 2016. Proposals were due in early 2017. The title of the call for proposals was The Future of Thwaites Glacier and Its Contribution to Sea Level Rise. The scale of it was about 25 million for science. They didn't specify the amount for logistics because it's so hard to parse this program versus everything else that's done in West Antarctica and the whole of Antarctica in the US program every year. About a third of the proposals were funded. These are major proposals. The scale of them was around $2.5 million each, actually closer to $3 million. The Science Coordination Office, which is one of the parts where I'm involved as the PI, the SCO is the Science Coordination Office, that was also funded at a fairly good scale, about $1 million over the course of 5 years. The proposals included the additional international components. Along with the US and the UK, early on, South Korea expressed an interest to collaborate in this area. And one of the proposals had a very strong collaboration in place with South Korea, primarily because of their research icebreaker. Sweden contributed an automated underwater vehicle, I guess, a research submarine, basically, that can operate underneath the floating parts of the ice shelf in front of Thwaites Glacier. Germany contributed a seismic source instrument called a VibroSeis, which has now been towed over to a waste divide and is about to be used in the coming field season. So this is sort of a general view, a schematic view of all of the different field observation steps that we're planning to take, including satellite data, but also on the adjacent nunataks, looking at rock samples, staging weather stations, collecting rocks for cosmogenic age dating, and quite a bit going on in the ocean in terms of moorings and CTD casts, AUVs progressing underneath the ice shelf, and then quite a bit going on on the ice sheet, of course, with traverses, radar, several stations, automated stations set up to make various kinds of measurements on the ice sheet as it progresses. And there are also 2 modeling studies that are supposed to make use of the observational data and take it a further step in terms of integrating it into a relatively short term, by ice sheet modeling standards, a forecast over the next century or 2 of how Thwaites Glacier will unfold. Also a look at the recent past, since the end of the last ice age, how Thwaites Glacier has behaved in the past few thousand years. As you can see, these boxes are sort of located near the processes, near where the processes would be studied. Thor collects ice cores looking at past history. Dominoes is a modeling study of the ice cliff front. Melt and Tarzan are both concerned with the ice shelf and the sub-ice shelf cavity and what's going on there. Prophet is intended to forecast what's going to happen long-term at Thwaites Glacier. Time and Ghost are actually just getting underway. They're concerned with the shear margin on the, particularly on the east side of Thwaites Glacier. And the general Ghost is the general environment and shape of the bedrock conditions at the ice bed interface. I didn't mention GHC. They're the ones that are collecting rock samples from the adjacent nunataks, mostly for cosmogenic age dating, but also GPS-based uplift and weather station information. It's a logistical necessity that we work together. No one nation could really undertake this because Thwaites is so remote and because the scale of all of these projects working together is so large that it takes the resources of actually several major Antarctic active countries in order to put the people and the material out there that's needed. So of course, we're using the LC-130s to bring a lot of gear to the West Antarctic, the Waste Divide camp in the middle of West Antarctic. The British Antarctic Survey has a well-developed science and logistical traverse capability that was necessary to bring fuel and other equipment to that Waste Divide camp, which is sort of the launch point for all of the work going on elsewhere on Thwaites Glacier. At least 2 ships are involved. We thought the Sir David Attenborough would be finished in time to be a part of this, but it's wasn't ready quite in time because of the extended sea trials that went on. Another look at sort of the geographics of where the different teams are working. The open circles are the modeling studies, and then the solid circles are the field studies. I think, I'm not sure what the different colors mean. I've forgotten why I discriminated with pale red versus dark red, but that gives you an idea of the scope in a geographic sense of who's going to be working where. Again, the proposals have been assembled in a way, and where the Science Coordination Office, which is overseeing how this all progresses from a research standpoint, and a little bit of the science logistical interaction, we've assembled these things in a way where we're hoping that the results from the observations and the results from the historical context feed the two modeling studies so that we go further than any one study can go. The whole reason for funding multiple projects at the same time and running them simultaneously is so that they can learn from each other and that they can synthesize results across the projects. That's what we're working on right now, although Time and Ghost are just getting underway. We're trying to synthesize the results that we have so far from MELT, Tarzan, Thor, GHC, and the modeling studies. Again, the compelling reason for the research is the threat posed by sea level rise, hard to predict sea level rise from the ice sheets, with some alarming potential rates of sea level rise forecast by the IPCC for the end of the century. And the whole marine ice sheet instability, which basically Thwaites sits in the center of an area of great concern in terms of how this modeled process would unfold in the future, and probably has unfolded in the past. The other thing that I'd like to mention is that there's strong existing partnerships. I think that's an important part of making this work. If you've got international partners, then talk to the scientists that have worked internationally with folks that study the same types of things in the partner country, and try to encourage them, build upon those linkages, because it makes for a much smoother execution of the research and writing of the final papers that'll be the outcome for the research. Lastly, this is sort of a quick snapshot of the research results so far. The floating ice in front of Thwaites is breaking apart. This has been a big concern because it looks like within the next few years, the ice shelf in front of part of Thwaites will break away, probably leading to some acceleration. We've done several trips underneath this ice shelf right up to the grounding line with AUVs. We've confirmed yet again, and in close proximity to Thwaites ice front, that there's warm, deep ocean water, basically circumpolar deep water, eroding the ice. Even a process where tidal action is actually lifting and pumping that water in, so that as you approach the grounding line, you're seeing much faster rates of basal melting. And we've gone quite a few steps further in understanding how ice cliffs work. Those are sort of the high profile results right now, but we're anticipating several more in the near future. So I'm done. That's our overview of the International Thwaites Glacier Collaboration. That's ITGC. I'll turn it over to Rob Clifton now for his assessment on AGAP and that international partnership.
You'll need to unmute, Rob.
Right, you should have me now, and you should have my slide, Nathan.
We do indeed.
Terrific. All right, well, thanks everyone. It's really great to be here talking about this. This is certainly one of the things that gets me out of bed in the morning and excites me about the work we do, is doing these big international projects to answer really big science questions. So it's great stuff. Look, in my talk this morning, I'm going to talk about the current state of international operations collaboration to give you a bit of background and a feel for how things operate normally. Talk about some of the benefits, the challenges, and also maybe offer a few potential solutions for those in the future. And I'm going to do a lot of that through using a bit of a case study and talking about a few previous expeditions and projects we've undertaken. So in the current state, we do a lot of international collaboration which I would couch as routine and sustainment operations. So not necessarily to deliver a particular program, but just to deliver our operations in general. And the way we do these is through annual quid pro quo or QPQ arrangements, and we have those with a number of nations. So some of the examples of that are, we have one with the Chinese program annually. We make fantastic use of their Basler aircraft. And then they in turn get seats on our Airbus or C-17 flights in and out of Antarctica. So that's a really great and productive relationship. We work closely with the French program. They provide annual shipping support to us to get scientists and others to Macquarie Island for us. And in turn, they then use their Basler to pick up their folk off our Airbus at Wilkins runway in Newcastle. And a classic one for many years has been a really great QPQ with the US. They've got a number of capabilities, including being the only nation that has ski-equipped LC-130s, and they're able to offer those to us in return for us providing Airbus flights into McMurdo from Christchurch and so on, which is a really great asset for them to have because they don't have that kind of commercial passenger carrying aviation capability. So these relationships work really well. They're generally based on no exchange of actual money, and they're really about an exchange of latent capacity that people might have in their program to get capabilities that they don't have or provide really good effect for their operations. So they're the QPQs for sustainment operations, and then we have project-specific collaborations, and I'll talk more about that in a short time. But an example of that would be the AGAP North project, or Antarctica's Gamburtsev province, back in 2008-9. And Thwaites that Ted's just spoken about is a classic example of where, you know, the collaboration is initiated by there first being a science collaboration that's built and then requires support. And the other one that's worth mentioning is emergency response. And we do a lot of operational collaboration in this sphere. It really is fantastic that people pretty much drop everything and help each other operationally when it's required. And some of the examples on the slide there are the vessel there is the Academic Schakowsky, a non-government ship that many nations came together to rescue essentially out of the ice. Bottom right, sadly, a 4-fatality helicopter crash in the French program that we assisted quite a lot with in the search and rescue and recovery operations. And the Chinese helicopter on the left is a great example of where a number of times the Chinese have come to our assistance, including just 2 years ago for medevac and search and rescue operations. And I'm always heartened that this is despite what might be going on in the South China Sea or globally in terms of international relations. So most of this is put together through COMNAP, or the Council of Managers of National Antarctic Programs, and the negotiation is done through that forum at annual meetings and on the sidelines, and also in the kind of intervening or intercessional period. And the photo is a great example. Rob Wooding from Australia, who is fantastic to see you in the audience today, Rob, signing up to the QPQ with China and the US. And just to give you an example, it gets kind of complicated in that China didn't have much that the US wanted. So the US got China to give us aviation support from the US to meet their QPQ arrangement, and it became this kind of linked tripartite agreement. So there's some great stuff that happens through COMNAP to make things happen. So let's have a look at a bit of a case study. Well, AGAP was a really, really large project, and you can see there on the map basically operations extending right through East Antarctica from South Pole down into the Lastman Hills area, Progress, Zhongshan and Davis Station. And it was a very ambitious project looking basically at geophysics throughout that entire area. And a whole bunch of programs came together to supply different aspects of the operational collaboration for the project. And it first came onto our radar in about 2006 And in fact, Ian Allison, who's also in the audience, and I went to a meeting in Shanghai to kick this off, where the international community was made aware of the kind of science ask, and then started thinking about how we might undertake the program logistically. And it was really clear from the outset that a program of this scale in the area that it was in could never be undertaken by one national program alone. No one had the capability or capacity, so it required that coalition building. Some of the examples of what people were able to contribute, well, obviously we were going a long way inland and we needed a lot of fuel. How do you deliver that? And the US program came to the party with C-17 aircraft and airdrop and delivered nearly 500 drums of aviation fuel into the field. Now, at this stage, no one else had this capability. The Australian Air Force wasn't even flying C-17s, and it really was our only option. And then we realised, well, we also need to get into the field and make a fairly rough off-field landing. The best aircraft for that, without a doubt, was Twin Otters, and the British Antarctic Survey provided them for that initial input into the field and also for ongoing survey operations. We then needed some additional cargo support in, and the Germans came to the party with Polar 5, their Basler aircraft. We shipped the cargo down to Davis on the Aurora Australis. They picked it up at Davis and flew it into the now established camp. The US program delivered people through South Pole by Twin Otter into the field camps, and Australia used its then main aircraft, which was the CASA 212. So as you can see, there were a bunch of niche capabilities. No one had them all, but they were all required to make this project actually happen on the ice. We largely used the field capability of the Australian Antarctic program, and that doesn't come without challenges that I'll talk about. I mean, it was a bunch of folk from other programs coming in and using Australian field systems and Australian safety systems. So that requires quite some pre-discussion and education, preparation and training, so that everyone's familiar with the system that they're using. Communications is always a big challenge. And I want to talk about this at the macro level, where it was very difficult across many time zones in the 2 or 3 years leading up to coordinate meetings and have discussions. They were almost all done in English, but that wasn't always easy for the non-English speaking parties to fully understand the language and keep up with discussions, of course. So we had to make sure we were accounting for everyone to be listened to and actively involved. And then down on the ice, when we get to a micro level, we encountered problems where, for example, our Iridium phones and the British Iridium phones couldn't talk to a US Iridium phone because the US Iridiums were going through a defence gateway. So there are all sorts of these kind of micro level collaboration challenges as well that we had to overcome, bringing these systems together. Of course, when you drop a lot of stuff into Antarctica, you create a lot of stuff that you've got to get out, and there are 100 cubic metres and 31 tonnes of waste to come out of the AGAP program. So how on earth do you do that? Well, you're not really going to do it by aircraft, and we scratched our heads about how that might work. And enlisted the Chinese Traverse, and they agreed to come via the AGAP sites at the end of the program and retrieve all the waste and rubbish. So again, meeting that requirement for good environmental stewardship required a capability that at the time Australia didn't have, and in fact no other nation had a traverse capability in that area of East Antarctica. But again, there were lots of challenges here with coordinating the timing and the route and the method of getting there for the Chinese to link up with multinational operations. So what was achieved? Well, on the logistic front, just to give you an idea, all of these countries coming together, we flew 240,000 support kilometres. That's in just delivering people, fuel and cargo. But significantly, we achieved 117,000 kilometres of scientific geophysical survey, which we were particularly proud about, and put out 26 passive seismometers as well. So it's the efforts of those 5 programs coming together that managed to achieve that. Just a few other examples. You might have heard of PC Mega many years ago. In fact, I was the field leader on this program, and it used a slightly different model where we adopted completely the Australian operating system and Australian logistics, and the German program just contributed funding for that. So that was, rather than bringing different logistic systems together, that was simply a case of choosing one, doing it all through the Australian system, but using funding from the Germans as well. And the Aurora Basin program is another great example of a successful international collaborative operation. We actually tried to get into the Aurora Basin, which is well south of Casey, in 2008. And we tried to do it by aviation alone, and we failed because when we got out there, the terrain was too rough for aircraft to safely do the camp put-in. And so we realised, really, to get into this area and drill ice cores, we needed to get in there on the ground. Again, the only people in the area with that kind of capability were the French, and they came to the party in providing a traverse into the drill site, delivering the initial cargo, and critically, knocking out a good, safe skiway for us to then put the rest of the camp in. Another aspect of the international, if you like, enabling of that project was the use of a Danish ice core drill and technology that Australia didn't have. So that's another couple of examples of how you might bring these coalitions, if you like, together to achieve really great outcomes. So what are some of the benefits? Well, obviously the achievement of these large-scale science programs, AGAP, PC Mega, Aurora Basin and Thwaites, clearly no one nation has the capabilities to actually pull it together. And so it brings multiple capabilities together that let us get more done. Significantly, I would also say it shares the resource load across partners. So that is, for example, for Australia alone to do one of these projects would pretty much mean we're not doing any other science. But if we're only contributing, say, 20% of our operational capacity to these big questions, we can still be doing a bunch of other work in Antarctica as well. So it doesn't become the sole program. And for us, extends what we call the art of the possible. So when scientists come to us with an ask about they want to go somewhere or do something, which we love, we hate saying no because we think we can't do it. And so if we know that we can call on the operational capabilities of other nations, then we know that we've got a really good chance of being able to say yes and actually achieving the science outcomes that the researchers want, which is fantastic. So there is obviously huge benefit in these international collaborations for science. Look, some of the challenges, definitely financial and planning structures and timelines of different partners. So it is quite challenging in the lead up to these programs, simply getting commitment out of different nations. Now, there are some countries we work with who genuinely don't decide their budget or their season plan until 4 or 5 months before the execution of a season. Now, Australia's moving away from that. We've been in a similar paradigm, but it makes it very difficult if you're planning 2 to 3 years out. So this is a real challenge that you need to work to overcome. Often people, nations programs can't give you an ironclad guarantee of support until very late in the actual evolution of the project, and that's a real challenge. I've talked about the communication with large numbers of disparate partners, different time zones. I think, for all of us, the pandemic's delivered this fantastic tool of people being super comfortable with these kind of forums. And I actually think that's an exciting development in our ability to pull together international partnerships and not need to be flying all around the world, meeting at different time zones, etc. Regulatory and legal disparities are definitely an issue for us and across all nations. In a way, this can often be the elephant in the room. It's not an easy conversation to have with another program to say, look, your aviation regulatory system doesn't allow us to put our people in your aeroplane or on your ship or in your field camp. And they're not easy conversations to have, but the reality is there are different regulatory and legal responsibilities in different nations, and we can't ignore those. So very early conversations and good understanding between projects about nations, about those different systems is critical in bringing it all together and making it work in a way that doesn't expose individual programs or countries to more regulatory or legal risk. Obviously, I've spoken a bit about the interoperability of technology and systems. More and more, this is becoming challenging. It's interesting to reflect, often reflect on the military systems where, for example, NATO has many agreed standards around, filters for gas masks or types of vehicles or the fuel they use, and everyone uses the same one to give them interoperability. Well, we don't have that in Antarctica. There isn't a COMNAP standard fuel or a COMNAP standard ration pack for the field. And so we do need to do a lot of work around that. An example would be when we did the AGAP project and Twin Otters started operating, we suddenly realised that the oxygen bottle fitting on a Bass Twin Otter is different than a NSF Twin Otter. And so we couldn't use one single oxygen bottle type. These sound like small things, but when you're in the middle of nowhere and you've delivered 50 of those oxygen bottles, it can be a bit of a showstopper. So there's a real challenge there for us. Differing risk appetites, look, that's also a challenge. It links back to that regulatory and legal disparity issue. But it is true that different countries have a different paradigm around risk and safety and different levels of what they'll accept. And so, again, you often need to have some quite difficult conversations about whether or not we can actually participate in the way that other nations would like us to. Differing concepts of operation is also an interesting challenge to overcome. When I reflect on PC Mega and working with the Germans, their paradigm in field science and geology was to do what they called cut lunch geology. That was to take their lunch, fly out of the main base camp in a helicopter, do their day's geology, and then fly back to the base camp. The Australian system was more around flying people out, putting them into a satellite camp, and leaving them there for 5 or 6 days at a time. And it kind of sounds strange, but that was a stumbling block. And getting everyone comfortable with different ways of operating and having a go at it took quite some negotiation. The other one that came to the fray on that expedition was the Germans were horrified we weren't going to have a facility for baking bread each day in the field, which was a major part of their diet. So it gets down to the micro level as well as the kind of macro policy level. And of course, operations management and coordination in partner silos is a real issue. So when you've got all these big moving pieces, they're all reporting back to different if you like, control or management authorities at home. How do you link it all up? We overcame that with the AGAP project pretty simply, and it worked really well in all agreeing that we would appoint one place and one person as the overall operations manager. And this was one of the NSF folk at McMurdo, and everything fed into that operations centre. And that worked really well. So when we were trying to coordinate a US C-17 dropping to an Australian ground party that had been delivered by a British Twin Otter, they were all talking back to one central point, and that worked really well. So although I say these are all challenges, and they certainly are, we know that we can overcome them. So some of the solutions that are evident to us now, obviously commence planning early. And I'd really encourage researchers, as soon as you start building your science collaboration, sow the seeds for the operational collaboration as well. Agreeing joint standards and protocols for individual projects can really lay a lot of problems and solve a lot of issues. And the other option is to ring fence parts of the operation and allocate it to one partner. So, for example, have one nation deliver all the aviation, one nation deliver all the shipping, and therefore you're not mixing systems and introducing that risk. Definitely establishing joint leadership and coordination arrangements is critical, and that example from AGAP and the US Operations Centre is a classic example of where that worked really well. And then, as we always say, check and test and check and test and check and test. And if you need people to talk to each other, systems to plug in, then standing in Antarctica is not the time to find out that they don't. So there are solutions. We've learnt those, we know those, and we now try and apply them as much as we can when we're putting these big collaborative coalitions together. Thanks very much. I'm going now to hand back to Nathan.
Nathan, you're muted.
Thank you very much, Wenniga. Thank you very much, Rob. Thank you very much, Ted. That was fantastic. We've got some questions going on in the chat there. And so what I'm actually going to, I've just realised I've now covered up the chat, and so I can't actually see it anymore. Let me just see if I can. That was no, it's not a blunder. It's all good. So what I would like to do, please type in some questions into the chat, and we'll work our way through those. And some of the questions have actually been already answered by Ted, but we might just read them out and have a bit of a conversation with them anyway, Ted. So Ted, make sure you're unmuted, and I see Rob still unmuted. Just one thing, Ted, there. When does the Thwaites program actually end?
That is a little unclear right now. It looks as though we'll be having some activity into the first half of 2025. One of the projects, Ghost, may actually have a season in 24-25. And so they would need to be supported, integrated a bit, at least to the end of 2025, having done a field season at the beginning of the year. That's in large part due to COVID, a little bit due to, even before COVID, the logistical challenge was steep and things were stretched out from the very beginning. And that's in the chat. There's a little bit of reference to that in the chat. So this is funded for 5 years, but probably going to be about 7 years for most of the projects.
Yeah, so that's, I think, a response to Ben's question there. How have you dealt with the season delays and the shifting timelines?
Yeah, it's tricky, and it seems as though most of the projects, other than Ghost in particular, which is only now getting started this coming season, are working together to try to merge what results we can merge together into broader publications. There are many publications already out for the ITGC, and some of them are collaborative across groups, but big picture syntheses are sort of being shaped now at an upcoming science meeting that we have in mid-June here in Boulder.
So, yeah, thanks for that. So there's a question here from Victoria. She asks, will you produce any research papers about the development, coordination and management aspects of the Thwaites program?
She says research papers, that implies peer review. I'm not quite sure where we would submit that to. In past international efforts, as part of the Larissa project, which focused on the Antarctic Peninsula during IPY, we came up with a paper that worked for the journal EOS, published by AGU. That's probably the target for the kind of paper Victoria is talking about. And yeah, the SCO has talked about writing that.
Great. And there's another question here for you, Ted, from Rob Masson. He's kind of wanting to know who or what initially instigated that US National Academy workshop and report.
Yeah, I'm not completely sure. I think NSF was recognizing that their official policy up until that meeting had been the best science is what we'll try to do, is what we'll try to execute, no matter where it is in Antarctica, if it's a strong enough science justification. I think, and they realized that that would be a little untenable going forward. I think in large part, the proposals that I mentioned that kept pointing to Getz Ice Shelf, Thwaites Glacier, other areas, ice domes along the West Antarctic coast was one I didn't mention, that those would require a focus and therefore a larger share of the logistics in the future. And they needed to have a report from the community that said it's okay to pick and choose a few projects, broad projects, things that had a big enough umbrella to bring in lots of different individual proposals. And there were three. I didn't mention all three, but one had to do with Thwaites past and present, the other on the genome of vertebrates in the Antarctic ecosystems, and lastly, cosmic background radiation, an upgrade to the experiment at the South Pole. So those things were sort of given a priority, and that might not be quite the right word, but an opening for proposals to be submitted on those topics that would have a slightly better chance of getting funded than new work on a glacier that hadn't been discussed in the meeting.
So thanks, Ted. I'm going to skip over a little bit and ask the question from Katie Marks. In that, to address to both of you, Rob and Ted. And here she asks if there's any work currently being resourced in the social sciences, humanities space to map social, cultural, and political aspects of these collaborations.
Short answer is no. That would be something the SCO would have to undertake as part of their work, and will be hard to fit something like that in without separate funding. I guess with the length of the ITGC, its success and the sort of well-known nature of the international effort, that might be something that would be proposed and funded in the coming couple of years.
What about you, Rob?
Yeah, I mean, I'd definitely say, Nathan, no, and no, and not enough. And I think there should be. I think the opportunity here, from my perspective, is that it could also be done retrospectively. So, it doesn't. That kind of work, I would assume, could look at the actual program or work as it goes on. But we know enough about a number of these programs and how they have rolled out, and I think there's some great opportunity there if someone wanted to look at, what's happened in the past and how's the evolution of these relationships been over the years, because I think it's, particularly strong now. It wasn't so, for example, 20 years ago.
Yeah, it's a changing landscape for this kind of stuff, isn't it?
Definitely.
So I've got another question here for you, Rob, from Ben Galton Fenzi. Really, it's about that, and it's relevant to you, Ted, as well. What is the good lead-out time to bring it all together? In your case, Rob, it's at an AAD perspective, and Ted, it would be from a NSF perspective. So, Rob.
Yeah, so look, I would say for these big initiatives, ideally somewhere between 3 and 5 years out from when we actually want to implement the program. At the very latest 2 years out, but coming at the 2-year mark, you would need to accept a risk that it wouldn't be possible just because of the time frame. It's doable, but much higher risk. Whereas I think you mitigate most of that, if you like, timeline and scheduling risk if you're in that 3 to 5 year time frame.
And
those are exactly the numbers I would have used, 3 to 5 years. I would add, I don't think it would be possible in the US program to start something even 2 years out. That's too close for a major effort like this. It would need to be 3 to 5 years. And there's a lot of groundwork to be laid. As I said NSF says they are community driven, but what that means is that people have to talk about it again and again and keep pointing to the high priority of whatever idea is out there and publish papers saying so and say so at meetings. And unfortunately, NSF wants what they call proposal pressure. In other words, write proposals to the NSF pushing in a certain direction. What they don't say is that, and those won't be funded for a while. You'll just keep writing them until we eventually decide that we'll do this work, which is not something that folks that work a lot with proposals, want to deal with. They want their proposals to have a good shot of getting funded. So it takes a lot of groundwork to get this going, and a lot of grassroots sort of push for 3 to 5 years, I would say. One more thing to add. We recently had a Dear Colleague letter from NSF. Basically, COVID and their objective of improving, in particular, McMurdo Station and some other things having to do with logistics. Things will slow down somewhat for the next several years, and it's unlikely that something like the Thwaites project would be undertaken in the near term after Thwaites.
Yeah, so headroom is being lost in the system to do the bigger project.
Fair to say. I think they're going to be eager to get those kinds of projects late this decade, but for the next few years, they're going to be focused on what they call AIM, which is massive restructuring of McMurdo Station. Certainly necessary. It's a shame that it has to, well, it's just got NSF's attention and a lot of their logistical capability tied up. Not all of it, but a lot of it. And they're not as entertaining of new deep field projects in the near term as they have been.
Yes, so I've got a question here from Hannah Nilsson. So thanks to Rob and Ted. Looking forward to what the priorities will be most important to develop in ensuring Antarctic work remains safe and accessible to a wider range of participants, and what capacity building should be foregrounded to support that. So this is a question about the capacities you need before projects happen. Maybe, Rob, that's best for you to answer.
I'm going to guess that Hannah's actually talking about things like social dynamics among field teams and whether or not they create a safe environment for people of color, their gender diversity in Antarctica. I'll let Rob answer it first if you want, but I wanted to make sure it was headed in the direction that Hannah had in mind.
I think that's in part what she had in mind.
Yeah, so I mean, look, I think it's about, from our perspective, it's about obviously having the capacity and capability to support people in the field, but then having those links to be able to share it. And I think also sharing it with emerging Antarctic nations as well is a really important thing, and to have an active program of bringing those people, if you like, into the fold and then helping them build capacity in their operations. So we've done that, as others have, with a number of nations who are, if you like, emerging in the Antarctic research sector, and then to kind of take them on our own programs and expeditions and capacity build within them, I think helps to develop capability throughout a bunch of developing Antarctic nations. So countries like India and China, and Poland and so on come to mind as they started to develop their Antarctic capability. So I hope that answers the question, but hopefully that's a way of getting more people around the globe and more opportunity for people to be engaged.
Fantastic. We've got 1 minute to wrap up. So I am going to suggest that actually that will be our last question for today. Thank you very much, both Rob and Ted, for that presentations around the. I thought maybe I was exaggerating when I said Herculean, but now I think that's a sort of understatement to actually make some of these programs really happen. We've got some great comments in the discussion down below. But thanks very much. I think it's fantastic, actually, what was talked about today. Thank you very much. And to the audience, thank you for coming and putting your questions into the chat, and look forward to our next Antarctic Policy and Research webinar. Thanks very much, everybody.